Hi, my name is Aditya, but it's called it's very difficult to pronounce an Indian name, so I call it Adi. Everybody calls me Adi here, and I work as a table manager at Pyth, and I'll be looking sometimes above, so don't get confused. I have two screens, so I'm presenting from above screen and the camera is down. So this is not kind of a workshop that you have thought. This is more of I want to keep it more interactive session. So feel free to ask question in between. I don't want to keep the ask me anything kind of a thing at the end of the workshop. So you can come uh, put any question that you have, and I'll try to answer during the workshop so that you have answers while like reading or while understanding the concepts, and you can easily get to know what coming next. So feel free to ask anything. Uh, Nevin, I just want to ask one thing. If anybody can open up their mic and say something, is it feature available?
No, this feature is not available here, but they will be typing their questions in the chat.
Okay, understood. So let's start. So this would be about Pyth and how we use Wormhole. At the current moment, I'm pretty sure you guys are more expert in Wormhole than me. So if I say something wrong about Wormhole, just tell me where I'm wrong. uh, I'll be more focusing on Pyth and how we use Wormhole to have the one of the best Oracle out there, and how we use latest data and we fetch pull data and we transmit via Wormhole. A brief introduction about Pyth. Pyth is a pull-based Oracle. You have seen a lot of push-based oracles out there. I can name them because that's what marketing guys told me not to name them explicitly, but there are a lot of push-based oracle that you guys know. You have used it. Whereas pull-based Oracle is we have to pull the data. So every push-based Oracle, they update the data on the chain. You read it from the chain. That's how it works. Whereas in pull-based Oracle, you will pull the data from yourself as a user, and you will update it on the chain and read it from there. That's the general concept. But I'll explain it like thoroughly. How we are different from any other oracles is we take the data from first party data providers, not like aggregators or like CoinGecko or CoinDesk, something like that. We go to like Wintermute, Jane Street, or these kind of people who owns the data. They send us data. We do a lot of stuff, which we'll explain in next slide, and we give it to a lot of chains. I think more than 100 chains now we support, thanks to Wormhole. So I'll go to the architecture first so that we just get started with, I want to introduce Wormhole here. As you can see here, we have those data providers that I told, like the first party data providers who owns data, especially the financial institutions. We take gold prices and that kind of thing, everything. They send prices. As you can see here, it's PythNet. This is a fork of Solana, I would say. We started with a fork of Solana. We made it PythNet, and we expanded it so that we can add more features. We take all data that we have that we're coming. We combine all the data and aggregate them. We put them into a message buffer and we send it to a wormhole. I really want to like anyone to guess why do we use wormhole? If someone can type it out, like why do we use wormhole here? Guesses.
Come on, everybody, don't be shy. Feel free to type in the chat.
Yeah, I'm sorry, I'll pick you guys. I can't see your names, but I have a habit of picking guys in the workshop so that they are more involved in this. Messaging to other bridges, yes. I think Lolo is from your marketing team because he just said best interop protocol for interoperability. Yeah, close. Yeah. So that's what I thought. Like even when I joined Pyth, I thought like, why do you guys wormhole? Do you want to just send it to every chain via wormhole? But Wormhole is more decentralized. That's the correct answer. Yes. Jinming, that's the correct answer. So Wormhole supports some chains, not all the chains that we want to support. And we thought of messaging, use Wormhole to send it to different chains and because it's best in probability. But Wormhole takes a lot of time to like sign the message from all the guardians out there. To prevent that and not having Wormhole as the like a bottleneck for us, we use Wormhole as a decentralized proof of authority. So at PythNet, we have all the prices aggregated and everything. At PythNet also, we have so many validators who are signing those messages and checking if every data is right or not. We want people at the target chain, the user on the right side, to extract from PythNet, take the data. They can read off chain as well, but update it on the chain so anybody can use it. But as a user, how would I know that someone is fetching the data from PythNet is correct or not? I can't be sure that is it really from PythNet? Are you not fetching from somewhere else? That was the biggest issue. In creating that trust, we use Wormhole. So we packed all the data, like allowed, I think around 10 to 20 price feeds we packed together. We sent to Wormhole. And how many guardians we have in Wormhole? I believe 19 right now. So all those guardians will get that price data and they will check it. Okay, like all 19 guardians, like we got the same price data. So 13, as soon as we got 13, two-thirds of the guardians accepted the data, they will send it ahead. So now this service called Price Service or Hermes, it's a open source service which fetches the data from Wormhole and from PythNet both and checks and combines together and checks, so yeah, it is right. And it sends to the contract. I know, like, if I'm going too fast, you can just stop and ask right now. I see no one is typing, so I'll go ahead. As a user, you will fetch the data from the Hermes and update it on chain. The contract already have the data from the Hermes that came before and that you sent it, and it checks again and it verifies the data is right or wrong. Like if it's verified, we have the right price data. So we do three verifications, one at the PythNet, 13 verifications are done by the Wormhole guardians, and at the end, we do it on the contract. The trust, because the price data is very important in DeFi application. You use it to lend something, you want to square off some positions or do any transaction. Prices should be right. So that's why we need to do verify a lot of times, and we don't want to be dependent on one thing. So that's why we have so many validators at PythNet. Guardians, we don't control those guardians. No one out there controls those guardians. So the guardians help us to verify the data and create that trust. And it's decentralized, as Adam told. Like it should be a top priority. And that's how the whole PythNet architecture is. And because of that, we can expand to so many chains out there. I can repeat everything again, or I can go slow. If you have any questions still now, I'm happy to answer that. Okay. Which part, Adam? Like any specific part, Adam, that you want me to repeat? From PythNet, yes. So suppose as a user, Adam wants to fetch some data and Adam wants to use price data like Ethereum price to buy an NFT, which costs like $100, something like that. And he wants to pay in Ether. He doesn't know the Ethereum price, and even the contract doesn't know. So if I say you can fetch it from PythNet and you can use it, you will say that I'm fetching from PythNet, but no one can trust you that you really fetch from PythNet or not. Is the PythNet price, because you're only one entity. So that's why we send the price. Why you will have to fetch it from PythNet, but we are also sending the same price via Wormhole which Hermes will collect and send it to the contract via Wormhole. Why? Because Wormhole, every guardian will fetch the data and verify it, and out of like as soon as 13 plus or 13 guardians verifies it, we will have more surety that the data that you have sent is equal to or equivalent to 13 more guardians who have approved it. So it's like proof of I can't say approval, but just to verify that, just to verify the data. That's more succinct, I would say. Yeah, I have some more questions coming in. So okay, perfect. What data do they verify it against? So they verify against each other. Like if one of the guardians say, no, I get a different data from PythNet, but you got a different data, then consensus won't be there and the verification won't happen. It's just like they have to verify that all of us are getting the same data at exact same timestamp, because prices are very volatile. So inside price object we send price, confidence interval, and the timestamp as well. So they verify amongst each other that we are getting the same data from the same source. That's how they're verifying. Is it like, do I answer your question, Sarvesh? Okay. So no, it should be 13 or 13 plus, because two-thirds of the guardians, there are 19 guardians. So we do 13, 13 plus. As soon as we reach 13, that is two-thirds of the guardians, we say the consensus have achieved, and that's how we do that. Okay, I, let's go to the next part. So people like usually get confused with push and pull oracle. Why do we need it and everything? I'll just show here. Like in a push oracle, user sends transaction to read the data, and they read from the Oracle smart contract, normal push oracle, and the Oracle smart contract. There's an Oracle network down there which sends continuous updates. Usually, these updates are 30 minutes or 15 minutes, based on the threshold. But you don't want 30 minutes old prices to work on it. You don't want to buy an NFT and if the Ethereum price or mother price has gone up and down. You don't want that. So in Pull Oracle, you fetch the prices directly from the Oracle network. You send the transaction with the price, the smart contract, and the Oracle smart contract with permissionless update and read. That's how it works. One good thing, like if suppose Arden has already fetched the price, updated it on chain, and does an operation, the price will be active for 60 seconds that we have set, but it is customizable. And now Servish comes or Adam comes to read the same price. He doesn't have to do the update because the prices are already updated there. So our Pyth smart contracts verifies that and see if the prices are stale or not. That's how Pyth works. All good till now? Okay. So I will now show you, like in 5 minutes, how you can start. How would a user know when to fetch the price from Oracle, when to not? That's a very good question, Service, honestly, because this happens when you start implementing it. So we recommend everyone, like either user or a DApp who has built it, to fetch the price all the time. But once you fetch the price and there's a method called update prices, which I will show in the demo now. When you put it, our Pyth contract will check if you need to update or not. So you don't have to pay the fees for update the prices. It will check automatically if prices are stale or not. So we recommend if you're working on something like perpetual or something really high frequency data you need, always fetch it as a safer side and push that data, like not push, like pull the data, put it on the chain. If it needed to be updated, it will update automatically. If not, it won't update. You won't spend any money out of that. I hope I answered Sarvesh's question. I'll get back to it if you have any follow-up question. And Aryan asked, in that push Oracle part, doesn't the reading data part permissionless? So yes, it's permissionless, but I have not seen any push Oracle where you. How would you pay to that Oracle? That's the issue. So you probably have to stake some token, some other contract, so that they can read it. Take your token in that from that contract. That's why they have to make it permission so that they can take money from you. We also take money from you in another way. I'll tell you how. But no one wants to give you the latest data free of cost. So that's how it's permissioned, and that's how ours is permissionless. Most of the Oracle you have to, I think, buy some token, put it on some contract as an escrow contract, and then start using it, something like that. Evgeny, I'm sorry if I'm pronouncing her name wrong. There are 19, she asked, or he asked, sorry. There are 19 guardians, but at least 13 out of 19 guardians need to have attested and emitted message on a source chain in order to product a valid attestation. Yes, that's true. Okay, she's typing. In the meantime, if you guys have any doubt in push and pull Oracle, I will do a demo about how Pyth works and how pull Oracle works on the code so that you have more understanding. Okay. In the So if you remember, we had this Hermes thing. Why it is a big, why it plays a big role, you'll get to know. So if you have to fetch a price, what things do you need? So there are three things that you need. One, which price do you want to fetch? Basic. On which chain do you want to fetch? Again, it's necessary. And the third thing is Hermes. So you need three things. Oh, product. My bad. Price feed, contract address of the chain, and Hermes endpoint. That's it. You need these three things. That's all. Nothing more. So if you guys can see, this is a contract, the basic ERC721 contract. If you guys are familiar with Ethereum ecosystem, I'm sorry if you guys coming from Solana or some other ecosystem. I will present an EVM ecosystem right now. This is a basic 721 contract. You want to mint an NFT. There's only one issue here. I want the NFT prices of $10, and it only accepts Ether, no stable coin, no USDC, no USDT. So I have to convert my Ether. That I have to convert my Ether. I have to check that if it's only worth $10 or not. If they're paying $10, or it should be exactly here, like $10 worth of Ether. For that, I would need Ether price, right? So how would we do that? So let's go to this. Let me zoom it. Is it visible?
Yes, it is. Thank you.
Maybe I can do a little bigger. All good?
Yep.
Yes.
Perfect.
Okay. So this is a contract that we will do. We'll work on this. So I will also show you how to go around the documentation and find things if you want to do that. So you just go to the Pyth documentation. This is Doc's landing page. Sorry, I was doing something. This is Doc landing page. We have a guide here. So we do support all of these chains. I'll zoom this as well. So I go to the guide. They say me to install my R SDKs, like Solidity SDK, which I've already installed. So if I can do this, that would, oh no, that would be bad. So they want me to install, which I've already installed. So if you see here, we have to use the ipyth, the interface to call anything, like any pyth function. And this is how they recommend me to do it. Like I have to get update fee, update price feed, and read the data. So I'll explain every single line how it works. So if you see the example here, there's some argument called price update. Can someone guess what's that price update? And random guesses would work. Yeah, Tom is here. Fetches the latest data. Yes, that's the price update. You fetch the data that I told you. You have to pulling the data from the Oracle. So we call it price update. So only thing I have to do here is if I'm minting here, so I have to call this bytes call price update. And one thing to note, it is a payable method. The reason of a payable method is we take fees as Pyth. We take fee when you update the price. Can you guys guess how much fees would that be to update one price feed? I've been asking you a lot of questions now, so I'll only answer. It's only one way. That's it. I don't. We have not seen anyone out there who is complaining that we have to pay one way for updating prices. So it's the lowest denominator on any chain, lowest denominator. So if you're going on Arbitrum, Polygon, or somewhere, the lowest denominator of every chain, that's the update fees. That's all. Yeah, we can't go any much cheaper than that. So that's what we do. So I'm copying these two lines so that I'm just showing how a developer should work. So these are okay. So we have to first do this. Yes, I missed that. How bad. So for the constructor, we need address of Pyth contract. So this is the constructor. We have to initialize Pyth for sure. And how I can get this address when I'm testing it. Just copy this as well. So if you want to get this contract address, you go to here. And if you see here, contract addresses, you click here. We have click on EVM for this right now. We support all of these chains. These are all the main nets. Even I don't remember, I don't know even half of them, how these network works. And these are all the test nets that we currently support. They're working, people are using it. So I take any, I don't know why, just like take a Gorley, Boba, something. I take this testnet, and this is the address that you will put here, the Pyth contract. So if you're deploying on, okay, let's go Blast. It's easy to say for me. It's a Blast Sepolia. If you go for Blast Sepolia, uh, you'll deploy this contract there. You have to pass that contract address, which is here. So now for the main function, you have to pass a price update. This is a Pyth method called get update fee, which will be one way always. But you can, since you can see it's an array of bytes, you can combine 10 price feeds together and you can send together. So for 10 price feeds, it will be 10 way. So the fees here, if you're sending 10 price updates together, it will be 10 way. And you get the fees, which will be 10. And this is a method you call update price feeds. This method, you'll take the message.value, which you'll be sending here, and from you'll just take the fee, which will be 10 way, and around the price update. This will update the data. The update price feeds method have another sub method which checks that do we really need to update that or not. So I believe someone surveys asked that question that how will we know if we have to update the data or not? This update price feeds will handle that automatically, that if we have to update that or not. If not, you won't spend a lot of gas there. Once you get that, you just have to read the price just like you do for any price out there, which is, if we open that again, Oh, we don't have the price feed ID. Yes. So this price feed ID is the one. Which price do you want to read? So at the price update that you fetch, it should be similar to that. How can I get that? So on the website, we have a page called price feed IDs. Let me zoom it. And you can just search Ethereum, ETH USD. So you also have an option like this is how we can show it. This is from crypto price, ETH BTC if you want, ETH USD. So I want ETH USD. I copy this and I put it here, which is exactly same that I'm copied there. And you just get the price. The price will have that price that you want. Along with the price, it will have four more things. I think I have to, it's okay. I have not installed it, but yes. So this is how you get the price. Then you can convert the price as you wanted to fetch $10 worth of price, and that's how it works. So there are three steps. One, you fetch the fees, like get the fees, how much fees I want, how much fees I have to pay. You update the price and you fetch the price. That's how it works. There's one question that I always get: how can I get this price update? Where is Hermes? I never showed Hermes in this workshop. Yes. So we have Hermes. I can, sorry, give me a second. So here you have fetch price update. This whole section. You can fetch the price via our REST API, via our like web streams or WebSocket, sorry, or we have TypeScript SDK as well, which you can include in your backend and you can fetch the prices. I can show you on the Swagger that how it works. So this is the one I want to fetch it for, like same one. This is the one I used, ETH USD. I want to make it on hex because in Ethereum system we use hex. As soon as I execute, the data that you can see here, this is the price update. That's all. And I selected here pass true, so it will pass the data and show me. So as you can see, the price for this is, let me zoom more, is this. The confidence interval, we also send that. The exponential, because it's sometimes 6, sometimes 8, sometimes 18 for some ERC20s. It's 8, and it's the published time. So the price will be like 3,465 because there are 8 zeros ahead using that. So you can use this price off-chain because you already have that. And you use this data, which was here, put it into the on-chain call that you're doing for minting or anything with the price. So you're sending the payload by yourself that, this is the latest price I fetch, use this to give me that. And the contract will check using the publish time here that you've sent the latest prices. That's how you pull the data first and update it, use it. Because there's no other way we have found sustainably that we can send you every data like quickly and you can use it without costing it. So you only pay one way out of that. And this data is getting updated every 400 millisecond. That's true. Every 400 millisecond, this data is new. If you see the timestamp, the price, they are changing. Why 400 millisecond? If we go lesser than 400 millisecond, it was very expensive for us, and we have to see the TPS. Solana is have very good transactions, like good TPS, because we're using a fork of Solana and we're working on it. So we came to 400 millisecond because that's the most someone asked. If they ask 200 millisecond, we have to expand it and make it 300 millisecond or 200 millisecond. We have not seen anyone out there who wanted less than 400 milliseconds. So it depends. That's how how much our network allowed right now. We can go even lesser than that, but we have to expand it and put some more resources to PythNet. Okay. So I have the call force checkout. I don't care. So after doing everything, this is how the contract should look like. Okay, I made it. Yeah. So in this case, what I did, I told people to pass, like you should pass the price feed ID separately, not hard coded. You can put price update, and this is the method I use to convert. You don't worry about normal maths, nothing special here. And the three things that you have to do: fetch prices, you have to get the update fee, update the price, and get fetch the price. That's all. And then this is how all, like, you can mint an NFT for specific $10. Yes, it is a bit different than any other Oracle out there that you just read the price, but you can't get the latest data from that. And with that 400 millisecond, they update after every 30 minutes. We give you after every 400 millisecond on any chain that you like. We have more than 400 price feeds out there. So that's how we use Wormhole to give you trusted price at that speed. 400, yes, that's true. 400 milliseconds is the current block time of Solana. We were on Solana before. Pythnet is a fork of Solana, but now the Pythnet doesn't even look like Solana anymore. So we have changed so much in that. That's why we have to fork it, and now we can support even less than 400 millisecond, but we have not went to that level yet. Like, no one ever asked us that, do you got, I need 200 millisecond data for something. So that's why we still kept it at 400 millisecond. Every operation that I've shown via Pythnet was happening on Solana 2 years back. We moved from Solana to Pythnet like maybe 1.5, yeah, approx 2 years back only. And now every chain that we support, all the data is coming from Pythnet, not from Solana. Okay. I don't see any other questions coming. Either I did a very bad job in explaining this thing, or I did a very great job. So there's nothing in between for me. Uh, okay. I I trust you, Tom. I trust you. Okay. So we have three products. Uh, I won't go very deeply into all of those products, but just say one or two lines. Oh, probably we have four products now. I have not updated that slides. Price feeds, I explained it. Benchmarks is a off-chain service that we say, off-chain service used for on-chain. If you want to get old prices, what price was there 5 minutes back? What price was there 10 minutes back? I want to get that. Why? There are a lot of lending protocols who want to square off positions even on half an hour old prices. We keep all those prices in an off-chain service and from the Pythnet where you can fetch it. When you fetch it, you can update it on chain via a method called parse. I think it was parse price feed. Yes. So we have an API reference here, which we are working on it to make it better. So parse price feed updates. You can fetch an old data, you can pass it on chain, and you can consume it there. So that's how benchmarks work. And entropy is a VRF function, like to generate a random number on chain. Doesn't it's very different from price feed. We don't use wormhole there, but it's a very different type of random function generator. We use two commit protocol where you give us a random number, we will give you a random number, we'll hash it together, and that will be the final random number. Yeah, we came up with that because it's much better. It's permissionless again. So that's how it works. And the last product that we came is Express Relay. It was launched on Thursday, last July 11th. Yes, July 11th, Thursday at ETHCC. It's more of a MEV protection protocol. I can speak hours on that because we done it last week only, but I won't spend a lot of time. I'll share you all the resources if you want to read more about the products which Pyth is doing. But this is the killer product that we have, and Now for the stats, these are the people that are using our product. So yes, okay. I'll come to your question, Andre. So just completing this. See, these are all the products that uh sorry, these are all the publishers down there. If you can see, these are all the blockchains that we support. Uh, and these are the products like in borrowing, lending, and fund manager platforms till June 2024, all the infrastructure and everything. So we have more than 400 products, 400 protocols who are using it. I will answer other questions before I have to answer Andre's question. Andre asked that uh, how Pyth is supporting the chains that Wormhole currently does not support. Yes, that's true. So we use Wormhole just to for the verification purpose by 13 guardians. That's so Wormhole is sending. We're not taking the data directly from the Wormhole. We're sending it to Hermes. Hermes is doing all that. Yes, we are via Hermes. Thank you so much for answering that. I think I've rushed a lot of things. I'm happy to explain things again. And if you don't like my voice, I'll send you my documentation. We don't have videos a lot because no good developer watches videos, honestly. So these are the like products we have. I think I'll keep this slide open and these two so that if you guys have any questions, we have a lot of time to explain it. If you want, if I get 5 yeses, I can explain entropy as well, how that works with code. Oh, I got 0. Okay, cool. So I got 4. I How similar is to chaining VRF? Sorry, I can't say that name. How is it similar to VRF? It's implementation wise, it's very different. Let's do that. So in the same example, suppose you want a random number so that you can put it there to get a random NFT or anything. I'll already have one entropy. Yes, branch. Just give me a second. Okay. So we'll just focus on this method here, line 22 to line 35. Fetch entropy random number. So, okay, I'll use Tom as a subject here. Tom is here. He wants a random number. So Tom says, I want to fetch a random number. He asks entropy from Pyth. Forget about the fees. He tell that there's Pyth here. Pyth has their own service provider, and you can implement your own providers as well. What is a provider? Provider is the one who will help you to generate a random number. So he will ask you to send me a random number by yourself, any random number, computed off chain or put it 1, 7, whatever you want to. So I give you my random number. Like Tom gives me random number. Provider has its own random number. We put it together, we hash it, and that will be the final random number. Tom will never know what Pyth random number would be, and Pyth will never know what the random number that Tom is sending it. Once they have committed to the random number, they can't change it because it's a hash function. If they change it, hash will change it. If Tom changes its random number, hash of that final random number would change. Basic hash function, how that works. So if you see here how it works, Tom is here. It's sending the user random number. This is Tom's random number. He tells entropy request with callback with the fees that he has to pay, and provider, to which provider he's telling. Right now there's one provider. You can add more provider of your own as well, and its own random number. When it goes, it will send you back a sequence number to remember that this is a sequence number. It is auto incremental. Then that provider will call this method, entropy callback method, with with the random number that you will use to mint an NFT. So if you see here, what I have done here, a person will come, he will just say fetch entropy random number. Fetch entropy random number will submit a random number that you will generate, and the provider or the pits provider, or it's not pits right now, it's we have given it to asymmetric guys to do that, but those people will call the this method entropy callback with a random number, and then you can mint your method here with that random number, random token ID. So if you compare it with VRF method, you don't have to stake their tokens, first buy their token, then stake their token, and then read the random number. You don't know how they read the random number because I don't know how they do that. I think they have some node running which do that. Here, the code for this provider is open source. If you're not comfortable using this provider, you can use your own provider. As you can see, uh, we give you the we give you the, like, you can put any provider who does this. It just have to call this entropy callback method. So we already exposed documentation how to run your own provider, but you can use the default provider that we have, which is called Fortuna, and this is the API for that as well. So for now, the entropy is only deployed on these chains. We are only expanding it where it is more necessary, not everywhere. And this is the the provider address that you have to put in the contract. So it's very different how the VRF or other random number works. Until unless Tom is truthful to his random number, sorry Tom to put you on spot, and the provider is truthful to its random number, it will work. And I think the current fee, oh, these are the fees. They're dynamically changing, but I don't think it's too much. It's like, okay, if I like 4 zeros and then 1 5. So this is the fees to get a random number, which is way, way less than any other random number provider out there, except on Zeta Chain and Clatylin, because they charge a lot. Because provider has to do a callback method. So we have to take fees for that because we're calling. So we are spending gas. So that's how the entropy works. It's very different. And if you really want to read about it, the same thing that I've explained, it's written here that A and B, like how does it work? Like classic commit reveal. Like you both commit to one random number, and then will generate a random number. Then you will reveal, yeah, my random number was this, and then you can verify. Oh, he was not lying. Oh, he was not lying, and that's how the commit reveal random number works. Okay. So I will tell you some things when you will be coming back to price feeds. If you don't have any question, if you have, I'll answer them. When you will try with the Pyth price feed, whenever you have time or in your projects, hackathons, anywhere, you will have to remember it's a pull oracle, not a push oracle. So if you go and just use get price out there like this is a method, you will get this error, stale price. The stale price means that in the past 60 seconds, this ETH USD on Arbitrum has not been updated yet. So that's why we don't want to show you the last updated price, because we don't like it can cause an accident or like an issue. Sorry, accident. It can cause an issue in your contract that you expected a latest price, but we gave you a very old price. So if it's not updated in last 60 seconds, it will give you a stale price. It means you have to update the price. But you're like, I don't want this method to fail anytime. You can use get price unsafe, which basically means the price you're getting will be unsafe. So this should always work. Yeah, the API reference page, I think we're working on that. So I believe, yeah, we have a new API reference page already up. So it's not like it's still in beta. So that's why I'm not sharing with other people. But this is how it works. So if I use get price unsafe, you get a price. You don't know if it's latest or not. This published time, I'm not sure if it's latest or not. So we have that get price unsafe and get price. So always remember the new kinds of Oracle. Every company out there, which Oracle companies are working on Pull Oracle, because real DeFi applications can't work with 30 minutes old data or 50 minutes old data. And they have to then, like, if they're updating a price on Ethereum, they have to put it on Arbitrum, Avalanche, and with so many L2s coming out, you can't update price everywhere. So it's better users and dApps pull the price in chain which in the chain that they want to use it, rather than we are pushing on every chain. So that's how new Pull Oracle mechanism work. So yeah, I'll keep the okay. It's already 48, so I'll keep the ground open. I will answer any last 10 minutes question, I would say.
Yes. If you have any last questions, now's the time to ask everybody. If not, until we wait for the questions to pop up, I'll ask the standard question. If people do remember later on that they have something to ask,
Yes.
where can people reach out to you on the socials?
I can give you my Telegram, my Twitter, or any of the Pyth's official website. Uh, I will be there to answer those questions. Either Discord, Telegram. Should I submit? Should I put it here only?
Yeah, feel free to pop it in the chat.
Sure, definitely I'll do that. This is my Telegram. I couldn't get my name, so I have to add BC again. That. So that's basically it. And feel free to ask anything. I think I have rushed a lot because I have to explain push and pull, then the contract, then other product. So if you don't understand, if you need to understand everything by scratch, I'm happy to do that.
No, it was a perfectly fine explanation, I think. Let's see if there were any. Need to say this is the really interactive most session. Not thanks. Yeah. Thank you very much.
Thank you, Adam.
Okay, we'll see if there are any final questions in a couple of seconds. Until then, I just want to take the opportunity to thank everybody for coming here regularly for the past 4 weeks. As you know, this is the final session of the Educate series, but it's definitely not the end of the collaboration between Wormhole and Encode Club this summer. We will be launching the Encode X Wormhole Hackathon on August the 5th. So if you haven't registered yet, feel free to register now. I'm just popping the website link in the chat. In line with that, I think an appropriate question would be, when people are building their own projects for the hackathon or for anything else, for any kind of purpose, what kind of a project do you personally like to see Pyth being used for?
So think of any of the Web2 application where it is dependent on latest prices. Mostly you will think about DeFi applications like lending, borrowing, or trading. I have not seen any app. I've seen some applications which are not dependent on DeFi. So I would say, think about that. The best way to do in any hackathon is not to see any Web3 people what they are building. Look at the people what they're not building, and see in your day-to-day activities what apps do you use, and do they really need blockchain or not. And using Pyth, see where you use prices almost day to day. And we don't only support crypto prices. We have gold prices. We have like meme coin prices as well. Some meme coins, not a lot. And you have stock, gold, stock prices as well, like Apple and everything. You can fetch that. Yes, Adam. So we were working. So Adam asked a question: is there anything you can tell us about that is coming up on Pyth roadmap? So we were working on this express relay part from past around 8 to 10 months, which is launched yet. Just a quick one line of express relay is you all guys know about basic things about MEV. So to put your transaction up in the block, you have to like pay a lot of money to the validator so that they put a transaction up in the block and your transaction will be processed. So a lot of DeFi protocols lose a lot of money in that. So we made a express relay server, which is off-chain and on-chain post, where you can mitigate that, and protocols and other people can earn money from that. So that was a big thing that if you asked me this question 1 week earlier, I would have said that. Now we are working on price feeds version, next version. We call it V2.5 or V3. We have not decided that, where we can support, right now we support 400 price feeds. Now we will be able to support more than like 1,000 price feeds with less than 400 milliseconds time. I have stopped sharing my screen for a second because I want to show you one last picture of our KPI so that you have idea what's next coming. Give me a second. Yeah, so I'll share it back. Yes. So this is our current right now for June 2024. So we are already expanding all the data providers from where we get the data. This much, how much volume that we already traded, how much blockchains we have connected. So we want to increase this 550 plus price feeds to every price feed out there. Like you want prices for some token that just got launched and no one is listing prices, but we want that prices to be there, that we support that. For that, we have to expand our Pythnet. So we are working on moving on working on Pythnet, so expand so that we can give you without any downtime, without any issues, those prices. Every price is out there. And we want to move move it to more chains. So we already got into Starknet. If you guys are building on Starknet, you can get all of these prices in Starknet also now. It just got like 3 days back on mainnet launch. We had it. So if you have to support so many prices and so many chains, we have to work on that Pythnet from where we do all the aggregation. So that's what we are working on. I hope I answered that
Perfect.
question because we don't have any new specific product that I can name right now.
No, it's a very good answer. Thank you very much. Yeah, I think this pretty much covers it. Thank you once again, Adi. Any final
Oh,
words for the audience?
uh, any final words? I think you guys already did a good job for signing up for this. I have done some encode workshops by myself. I've been a student, and how they curate the structure, it's good. And wormhole is not an easy thing to learn. Even I don't know how that works. So you already done these workshops, so I have nothing to say. It was just a small, tiny bit I've added to your knowledge.
And it was
And
a
I want to,
pleasure.
yeah,
Yeah,
I
go
want to
ahead.
see some projects coming from you guys, like hackathon, small, big. I'm happy to see that.
Yeah, I'm sure you will. And it was a pleasure having you. Thanks once again to everybody else for coming. Don't forget to register for the hackathon again, launching on the 5th of August. Until then, have a lovely day and have a lovely rest of your month. And we'll see you later on. Bye,
Okay.
everybody.
Thank you. See you.